All right, so the last thing are our last two measures of spread or dispersion or variance or variation, whatever you want to call it, or variability. One is variance. Variance is literally just the standard deviation squared. So I'll take a moment and write that down. Our variance is equal to S squared. I don't tend to use variance very often because the nice thing about S, or the standard deviation, is the standard deviation has the same units. So I'll write that over here, same units as our x's, right? Whereas this is going to have units squared. So it makes it a lot harder to actually interpret and really visualize, because we'll get some visualizations for that standard deviation as well. The other one, I've had a lot of students over the years who have been clever enough to, when we were doing all the standard deviation stuff, to say, well, why do we have to square it? If you're saying that we're doing squaring to make it fair, that above and below is just the same, why don't we just take absolute values instead of squaring? And there is a way to do that. So the mean absolute difference is doing exactly that, taking each value, how far away it is, and then just saying whether it's positive or negative. It's very similar to standard deviation. It's just not used as much in all of the other stuff we do later. So while it exists and it's a good measurement, it's not one that I really will spend any time on besides telling you right now that yes, it does exist. If you thought about that when I was talking about standard deviation, you're a badass. Pat yourself on the back. All right, so which measures should you be using? Well, we talked about range being silly, variance having units that aren't terribly easy to interpret, and that MAD being fine, but not used in everything else later in the class like standard deviation is. So the two that we care the most about are IQR and standard deviation. Remember, our IQR is the middle 50%, that range, and our standard deviation is how much everything deviates from the mean. So just like our median and mean, they fit with depending on what our distribution looks like. So just like the median, the IQR is the best for skewed distributions or distributions with outliers, because it ignores that top 25 and bottom 25%. It ignores any outliers, that very extreme values to either end. The standard deviation, it takes everything into account, just like a mean, and it uses the mean. So it's going to be your best measure of spread if we're dealing with symmetric distributions. As I have a note here, variance and that mean absolute, absolute difference. Yes. They are, sorry, I don't ever talk about that, are also good measures, but they're just not ones that I'm going to be using. Properties for every measure of spread, regardless, they're all going to be greater than or equal to 0. They have to have strictly 0 or greater, because there's no such thing as being negatively spread. 0 would mean that there is no spread, right? Up to lots of spread. The closer they are together, the smaller the spread, just like we saw in that standard deviation example, and the further apart, the larger the spread. So the next video is going to show us how to do everything that we've just tackled in 2.4 in our calculator. So I will show you both the graphing calculator, and there'll be a separate video for the TI-36X. So the first video will be graphing calculator, and then we'll do the TI-36X. So watch whichever one for whichever type of calculator you have. If you have a different type of calculator, chat with me in class and we'll see if it can do it.